So in this video we want to look at techniques for solving basic sine equations that have stretches, compressions, and translations. So the problem that we have as an example is the equation 2 sine 3 theta plus the square root of 2 equals 0, and we are asked to find the solutions on the interval from 0 to 360 degrees. So the first thing that we want to recognize is that on the interval from 0 to 360 degrees, which is one period or for the sine function, or once around the unit circle, there are generally two places where the toolbox function sine of theta is equal to the same side ratio. So for example, if we have a y coordinate here, x and y, the sine is always going to be the y coordinate, and there will be a spot over in quadrant 2 where we have opposite of x comma y, where the y coordinates will match. So usually for the sine function, in most cases, for the toolbox function, if it's equal to something, you expect to get two angles that generate that output. So that said, before we even start working on this particular problem, what we can identify is that if we have a multiplier of 3 on the input variable to the sine function, that means things are happening 3 times faster. So instead of 2 solutions, which is what we would expect for sine of theta, we're going to expect to get 3 times as many, or 6 solutions. And a smart thing to do that I'm not going to do in this particular video, but it's a wise thing to do if you're working through homework, is to graph the equation over the interval you're interested in. So you set your window to this input interval, and you can count how many solutions there are to that equation, just as a way to kind of warm yourself up before you start the solution process. But I'm expecting 6 solutions on this interval because of this multiplier of 3 making things happen 3 times faster. So the solution process is going to be to rewrite the equation, and then we want to isolate the sine function, so we're going to subtract the square root of 2 from both sides, and then we're going to divide both sides by 2 to get the sine function by itself. Then we're going to take the inverse sine of both sides to knock the 3 theta out from inside of the parentheses. We want to recognize that this is the principal angle that generates the side ratio negative root 2 over 2. And as we saw in video 1, I believe it was, we should get 2 angles. If we have an angle theta 1 that generates this side ratio, there should be an angle theta 2 that is the supplement of it, so that adds up to, we're in degree world, so that adds up to 180 degrees. So we should get the principal solution plus the supplement to the principal solution. So we expect to get a second angle that generates this side ratio, and it's going to be 180 degrees minus theta 1. So our second solution is going to look like 3 theta equaling 180 degrees minus the angle, which is the sine, it should be inverse, sine inverse of negative root 2 over 2. And then we want to recognize that every angle coterminal with this angle generates this side ratio. So because we're working in degrees, we're going to go plus 360 degrees times k, where k has to be an integer. And over here it's going to be plus 360 degrees times any integer k. And then for our next step, we want to look at the sine inverse of negative root 2 over 2 and say, hey, does this side ratio correspond to a special angle on the unit circle? And if it does, we want to get that angle. We want to remember that the sine inverse only generates outputs on the interval from negative 90 degrees to 90 degrees. So is there an angle between negative 90 and 90 that's a special angle that generates negative root 2 over 2? And there is. So at negative 45 degrees, we have the ordered pair, positive root 2 over 2 comma negative root 2 over 2. And the sine function is the y-coordinate on the unit circle. So that means that we're going to get an angle of 45 degrees generating the side ratio. So I'm going to simplify to 45 degrees plus 360 degrees times k. And then what I'm going to do to get theta by itself, I'm going to multiply both sides by 1/3. So 1/3 of 3 is 1. We get one set of solutions given by theta equals 1/3 of 45. So 3 is going to go into 45 15 times. Plus 3 will go into here 120 times k. There's one solution equation. And then we do the same thing over here. We get 3 theta equals 180 degrees minus the sine inverse of negative root 2 over 2. We just saw over here was it was negative 45 degrees. That needs a negative sign on it. So that should be a negative 15 degrees, 1/3 of negative 45. So this would be 180 degrees minus negative 45 degrees was the angle that generated this side ratio right here. Plus 360 degrees times k equals, we can do a little simplifying, so 180 minus a negative, that's a double negation, so this is going to give us a plusy, and that's going to give us a 225 degrees plus 360 degrees times k, and then we can multiply both sides by 1/3. So we'll get 1/3 of 3 is 1. We get 1 theta equaling 3 is going to go in there 75 times. So 75 degrees plus 360 degrees times k. So here's a second set of solutions. So these two together also actually represent all solutions. What we want is the solutions on the interval from 0 to 360 degrees, and we're expecting in most cases each of the equations to contribute an even number. So one of them usually is going to contribute 3 of the 6 solutions, the other should contribute the other 3 of the 6 solutions. So for this first one, I've got the negative sitting here. So to get this positive, I can see that I'm going to need to let k equal 1. So it looks like we probably need to let k equal 1, 2, and 3 to generate 3 solutions. So if we do that, we're going to get theta equal to negative 15 plus 120 times 1, negative 15 plus 120 times 2, and negative 15 plus 120 times 3. And then we can simplify these. Be negative 15 plus 120 is 105 degrees. Negative 15 plus 120 times 2 is going to be negative 15 plus a 240. And I get negative 15 plus 360. And then we can simplify those a little bit more. This will be 105 degrees, comma, negative 15 plus 240 is going to be 225 degrees. And this is going to be 345 degrees. So there's 3 angles, each of which is clearly in the interval from 0 to 360 degrees. And then we step over here, we can see if we let k equal 0, we're going to get a positive 75 degrees corresponding to an angle between 0 and 360. So to generate 3 solutions, it looks like it's going to be k equals 0, 1, and 2. So sliding those in, we get theta equals, we get 75 degrees plus 360 times 0 is just going to be 75 degrees. We're going to get 75 degrees plus, I did 1/3 of 360. I didn't distribute the 1/3, and see that 1/3 of 225 is 75, and I got wrapped up doing that, and then I made that distribution error that gets a person marked down so good. So 1/3 of 360 is going to be 120 degrees times k. The better question is, how did I know I made a mistake? And I knew that because 75 plus 360 was going to take me way out of my interval of interest, so that told me I had a mistake. So it's going to be 75 degrees plus 120 degrees times 1. And it's going to be 75 degrees plus 120 degrees times the 2. And then we do some simplifying. 75 degrees plus 120 times 1 is just 120. So 75 plus 120 is a 195 degrees. And this is going to be 75 degrees plus 240 from here. And then that needs to be simplified. We get 75 degrees, 195 degrees, and what's that going to be? 315 degrees. And all three of these are in the interval from 0 to 360, so they all look good. And usually you want to put them all together into a single set of numbers. So theta is either equal to 75, 105 if we put them in ascending order, 195 coming from here, 225 coming from here, 315 coming from here, or 345 degrees coming from here.